Good morning, students. I wanted to talk about the investigation you guys did around surface area in the last class period, and then extend that into teaching you formally how this stuff works. There were lots of different methods of investigation that students used. Here's what a lot of them looked like. People were drawing the net for whatever type of 3D prism we gave you. This net is great, and then people label all the sides, find the areas of those pieces, and then finally you'd sum up all of those areas to get the surface area of the whole thing, which is like the wrapping paper that would go around the outside of this prism. So great, if you had methods like this, I super support that. Here's another way students labeled it out. I really like the way this student did this. So you see, like, number one, they drew the net over here, they labeled the pieces they knew, and then they said, for number one, here's how the squares work, and they found the area of all the squares. For number one, here's how the triangles work, and they find the area of the triangles, and then the area of the whole thing, they added up the pieces they need. Great, I like that method of investigation a lot. So then students were taking steps towards formulae. So you're going from where you know numbers specific for side lengths into now you don't know numbers. Now these are like variables like H, W, and L, and whatever, however you label it is fine. So some students had work that looked a lot like this, where you're drawing this thing and then trying to say what's the area of these pieces and adding them up. And you can see this student is still dealing with numbers specifically, but what they're trying to do is approaching the formulae. I really like this student defined their variables. This is super important actually, and we'll talk about that as we get further into this. And then this was a different student they defined their variables the same way, but they didn't specifically say what those variables were defined as. I like that this student told me what these things are. This student then, and they were looking at, volume and surface area, good. They were looking at coming up with these surface area formulas by using the same things they were doing up here, but just trying to generalize these. Instead of being like 2.5, you'd have H or L or A for apothem or whatever the piece is. So cool, that shows how we're approaching formula. This student is the same student that defined their variables, and you can see what they did is great. They drew the net in general for the triangular prism. They came up with the individual pieces. Here's what the areas look like, and so the surface area has to be adding those things up. And there's 3 of these squares and 2 of the triangles. So this would have been multiplied by 2, but the area of a triangle is like base times height times 1/2. So when you multiply that by 2, they just get one of those things. Great, okay. Same thing, they had the cube, great, and they generalized and found their formula. Then they had the pentagonal prism. They did the exact same thing, generalizing and then adding those things up. This is exactly the type of thing I was hoping you guys would end up with. And if you were ending up with formulae like these, then you were definitely like finishing this entire investigation and coming up with generalized formula that will work for every different polygon. So let's formally generalize this and look at it. I thought it would be more useful to look at this like visually using the nets that you guys have drawn. So we're assuming a regular pentagon, meaning all of the sides on this pentagon are equal and all of the angles in here are equal. We have to assume that because my drawing is terrible. Like, it's obviously this side is far longer than this side over here, like way longer. So my drawing is not great, but we can see that we have side lengths. I've put them all in red, and all of the things with red dots are equal to each other. Those are all the same value or the same variable. Same thing with the heights. These heights here, if you wonder why I call that height, it's because I think of these things being this way, where we have a base on the ground, and then the height of this thing is here. So I'm inclined to call like this side a side length, and this side a height. And so that's going to be the way that I will label these things going forward. So the side lengths of the base are always side lengths. And then the side length that's not a base side length that's on the rectangles is the height. I hope that makes sense. I guess if not, just let me know and we'll chat about it. Good. So then if I want to come up with the area of these things, well, the area of a pentagon, we explored that, I think, last week, but recently. So the area of a pentagon, I would take my pentagon, cut it into triangles like this. We know this piece here is the apothem, this piece here is the side length. So 1/2 times the apothem times the side length gives us the area of that triangle, and then multiply by the number of sides because that's how many triangles give us the area of that thing. Great, okay, so we remember this formula. So our surface area has 2 of those pentagons, like 1 and 2, and then 5 rectangles, because there's 5 rectangles here for the 5 sides. So I would have 2 of these pentagons, which look like this, like, why did I put there's 5? Oh, because it's the number of sides times 1/2 times the apothem times the side length. So this would be the pentagon area, and then multiply by 2 because there are 2 pentagons, plus 5 of these rectangles, which are just the side length here times the height there. So good. And then we can continue generalizing this to say that here I define my variables first of all. I should have noted that. A is the apothem, S is the side length, H is the height. So I've gone here from, we use colors, now I'm actually labeling these things. Apothem, side length, height, and this formula works for every pentagonal prism, all of them. The last thing I'd note is that we can remove the fact that this is a pentagonal prism and talk about prisms in general, as long as we realize this 5 and this 5 came from the fact that pentagons have 5 sides. So n is the number of sides. We can take this surface area formula and we can generalize it further. The surface area of a prism with a base of a regular n-gon. So n-sided polygon is what an n-gon means. So we have n sides on this polygon, in this case 5, because it's a pentagonal prism. I'm taking this same formula, surface area equals 2, like surface area equals 2, but instead of 5 here, I'm putting n because that's the number of sides, times 1/2 times the apothem times the side length, plus the number of sides times the side length times the height. That's the rectangles in the middle here. So we have this generalized formula. There's one last thing I want to note about it, and I pulled up pictures here to talk. So we have side length here, we have height. I could put in, if the center is somewhere near there, and the middle of that side is somewhere near there, then we also have apothem. Great. And then n is the number of sides in general. So, so good. N is number of sides, A and S are apothem and side length, N is number of sides, S and H are side length and height. And now we have this generalized formula. The last thing I wanted to note is that sometimes sometimes prisms in general are oriented the way that I like it, where they're sitting on the base. But sometimes we give you them and they're not sitting on the base. So when they're not sitting that way, you still have to be able to recognize that height is now like along the ground there. And these things will be the side lengths. This thing would be a side length. And again, I could draw in these apothems, which just makes me realize I don't know the plural of the word apothem. Is it apothems or apotha? It could be apotha if it comes from Latin. It probably comes from Latin. It sounds Latin. Anyway, so apothem goes there and apothem goes there. So just to note, that's how we would label these things. And then in this case, the number of the n value here would be 3 because this is a triangle. N here would be 5 because this is a pentagonal prism. Let's look at your guys' assignment real quick. So in this assignment, first of all, we have find the surface area of these prisms. Great. You have a formula, this formula right down here, that you can use just to jump to those answers. So just label what's your side length, what's your apothem, what's your pieces, and then find the surface area. This one actually might be easier if you just add up the 6 sides. But these ones, I would definitely go about it different ways, like using the formula. Good, so, and especially these ones, because the apothem is drawn on there. I guess what I'm saying is, the apothem is drawn on these, I would use that. But in these other ones, like maybe you don't use that. This isn't a regular n-gon, so you just have to find all of the area of all of the sides and add them up in that case. But when you have an apothem like this, you have regular n-gons, you can apply that formula. That's what I mean. Now in this next one, we tell you that these are prisms with certain regular bases. So here you definitely use that formula for everything. And then in 3 and 4, we end up with word problems, which will take you a bit longer because you need to read and decode them. If you have trouble reading and decoding these, get in touch with me because I'd love to help you work through them. And yeah, if you don't have trouble reading them, you just get right through it. That's great. Just submit your work. But if you need help, let me know. Best of luck, and I'll talk to you guys soon.